Hi, my name is Erik Schmauss, and I work in the ACPI CA group at Intel. ACPI CA stands for ACPI Component Architecture, and it is an open source software project. And our project, we create a bunch of ACPI firmware tools so that firmware developers can create ACPI tables more easily, as well as to debug them more easily as well. Today I want to share the state of ASL programming from the perspective of the tool's developer. And this comes from the things that I've seen in people and things that I've heard from interacting with other people. So a quick overview, what is ACPI? Well, broadly speaking, it is a firmware interface used by the operating system to enable device discovery, configuration, as well as power management. And the ACPI specification outlines a language for a data table, which are basically key value pairs, as well as executable bytecode called AML. And there is also the human readable format of the bytecode called ASL, ACPI source language. So what is ASL? It's a language, again, it's the human readable format, and during firmware development, ASL gets compiled to AML, and then the AML then gets executed by the operating system after boot time. So broadly, the development kind of looks like this. I may be generalizing here, but we start with a hardware specification of some sort. We generate ASL. The ASL gets compiled to AML, and then a set of these are collected, and we will call these the ACPI tables. And upon boot time, the operating system will load these ACPI tables to create a namespace of these objects. So then the operating system kernel or device driver can query the AML interpreter to evaluate some values, like, for example, OSI, or the address or location of this or that. So now there are a few challenges with ASL, and I'd like to I'd like to take some time going over them. So there are three main points. So one of them is that we have identified a shortage of skilled ASL programmers. And it is clear from asking different groups to say, well, what happened here, or who wrote this? Oh, this one person or a small collection of people wrote them. And so it's clear that there is not a lot of knowledge that's dispersed on how to write firmware tables. And the second is that the firmware code is increasing in complexity. So on some platforms, there are many different configurations. So the firmware developers decide, well, we want to have one ASL table that can take care of all these different configurations. And that leads to more and more complicated approaches to generating ASL, as well as writing and debugging this. And the third is that the firmware code for new platforms is often copy-pasted from older platforms. And so with the combination of these three, we have poor code quality. So we'll go over a few of these. So here's the first one. So this is in ASL syntax. This declares a named object called object1 and assigns it to the value 0. And on the very next line, we assign object1 to the value 1. Now, this isn't per se bad code. It just could use a little bit of cleanup. This second line is not necessary. We could just declare the object1 to be the value 1. Right. So this is more of a stylistic point of view, but I have seen this kind of code out there. The second is that, let's say that we have this method called _PCD, okay? And M001 is a method that returns a reference, and we are trying to assign the value into one. All right, and this actually results in a runtime error when we run the function _PCD. So what that means is that so in the context of control method executions, or method executions, when the interpreter executes this function and runs into an error, it actually aborts the execution of the method. So if we have anything after this line of code right here, then it does not get executed. So this is getting a little bit more serious. So, and the next example that we have is a little bit more tricky. So in this context, we'll assume that there are multiple ACPI tables, executable codes, okay? And the external declaration allows the ASL programmer to say, device 1, dev1, is declared in a separate table than the one we have declared right now. And this basically tells the IASL compiler or other compilers to say, trust us, this thing exists. All right, so then we go on to define a package, which can be thought of as a C structure of sorts, okay? And so we define a package and we reference dev1. And I've seen a good amount of cases where dev1 is actually not defined in any of the tables. So we're referencing objects that do not exist. Some of these people come and ask me how they can fix this, and I don't really know what to tell them except to contact their firmware vendors. But from a general standpoint, we don't know what dev1 is, so this is actually quite scary. So I've outlined some of the challenges, and here are the impacts. One, it gives some users, so some AML interpreters end up telling end users a bunch of things that went wrong during boot. And this can frighten users. And, but more importantly, runtime errors during AML evaluation will abort the execution. So this means that if a firmware developer wrote certain ACPI tables and there is an error, that functionality that they thought that they implemented is actually not there. So what can we do about this? So I think there are 3 things, maybe 4, that we can do. So one of them is to use the latest ASL compiler. Now, the reason to do this is to create better ASL code, because we constantly work on these compilers like IASL. We constantly add new errors. So it could improve code quality there. But also, we need to be running this and testing AML using a user space interpreter. A lot of the issues that I see end up being debuggable by running it in user space, meaning that a lot of these issues are related to just people needing to run this to verify that it is the expected behavior that they had thought that they programmed. And another one that I am working on right now is to create an ACPI firmware development tutorial. This introduces ASL to firmware developers and other people who want to learn ASL as well as a language. So we will start off by saying these are the types of the language. This is like the scoping rules. And this also outlines the best practices on how ASL should be used. And the last point that I would like to make is that if you know anyone that writes ASL, or if you write ASL yourself, we would like to hear from you guys about what you have to say about the language or what make it difficult to develop ASL. Anyway, with that, I would like to open it up for some questions. Yeah.
So I was just asking if you guys have considered adding MSR accesses to ACPI tables so that you can generate ASL code that accesses MSRs directly instead of having to route through an SMI handler?
I don't think we have talked about that. I don't recollect. But again, these are things that we can bring up in the ASWG meeting as well.
I just thought I'd mention it because it's something that I've seen that's been lacking in ACPI for a long time.
I see.
That I see Wild Doran has appeared, and perhaps yeah, this seems like also a crossover between like an interface issue and a spec issue. So Mark may want to kind of cover some of the distance here.
So with respect to that question, the answer is yes, we have considered adding access to MSRs to ASL before, and we have opted not to do that to keep the sandbox from getting a little wider with respect to access of things that are model specific. It makes the firmware that much more tied to a particular piece of silicon. However, it's 2018 now. The definition of ASL hasn't seen any major revision aside from a few syntactic things to make it look a little bit more like C around variable assignments and things of that sort in a very long time. So this is not necessarily an official thing per se, but I have a particular interest in maybe opening a conversation with anybody that would like to think about whether it's time to revisit ASL and consider again things like MSR accesses and various other things that we might do. And I have an ulterior motive here. Again, a personal agenda. This is an Intel fellow speaking, so I'm not talking for the forum here for a second. It would not break my heart if we were, as a community, less dependent on SMI handlers. And one of the things that might be very interesting is moving some of the things that today are in platform-specific code in SMI handlers into ASL. But the first thing we run into is ASL isn't expressive enough to do a number of platform things. So for anybody that's interested in that conversation, I'd like to sort of get together and maybe talk about what we might do and whether there's something practical we could do with the definition of ASL. I'm going to make Erik's life hell because that might make a lot more work for the tools, but I think there may be some upside benefit to all of us in looking at that question. So if you're interested, please come find me and let's figure out who's in for that conversation.
Actually, Mike, why don't you take that microphone? I'm gonna make Mark do more work. While we're waiting for that microphone to end up on the other side of the room, I do have a question, because a number of the examples you gave of bad code, I would have looked at those and thought that, especially with like non-declared objects and sort of this won't return the way you think it's going to return, I would think that in most cases a compiler would normally catch that. So what makes ASL different so that type of scenario where like you've got an integer that obviously doesn't return an integer, or you said I'm relying on this variable or this thing and it's nowhere in the namespace. Is there anything unique about ASL that causes those issues to happen?
Yes. So regarding, let's see where to start. So with a non-existent object, it becomes a little bit more difficult because there is, in the ASL language, there is the load and unload operators, which will load and unload entire tables. So there weren't any checks to within the compiler to enforce something like that. To be able to deterministically say, okay, well, we have these names, right? And I believe we can do this conservatively, but from what we find out about how developers are using this external keyword, it seems that there is a a divergence between the specification and how it is actually used. Now with the example of, let's see, the wrong types, for example, we have, there are certain keywords that would declare something as an unknown object type, as well as the method parameters to methods are not typed either.
Okay.
So there are various aspects of the language that are basically the equivalent of casting to a void pointer in C and then casting back again.
All right. So. Did the other microphone find its way to an inquisitive person? Yes, it did.
So yes, do talk to me about the language. I would love to get. I'd also love to get it out of the spec, so that it's a little more flexible. So from the open source standpoint, I maintain the packages on the Debian and Fedora distribution for ACPI CA. And a couple of things that I'm curious about is, how can we get more insight into what's coming? That's been a really, really hard problem, because I'll get bug reports for various and sundry things, and be ready to start fixing them and send a patch, and then a new version of ACPI CA comes out and you've already fixed it, right? So is there some way to get some more information on what you're planning for the next release and what that might look like?
Yeah, so we do a lot of our work on Bugzilla, on our ACPI CA Bugzilla, and there is a on the Linux kernel Bugzilla as well, there is an ACPI section as well. So in terms of what we expect to land upstream, you can track issues there as well as on the GitHub account as well. We try to do a release about every month or month and a half.
I track all of those.
Oh, okay.
And I do see all of those. And I mean, for example, there's 3 security bugs. Speaking of security.
Yes. Yeah.
You just accepted one, but I can't get a good answer on when the other 2 will be accepted.
I see. Yeah, we're currently working on those right now.
So stuff like that.
Yeah.
It'd be really good to be able to know when stuff is coming.
Okay.
So I can convey that to the folks that do write ASL, that get badgered about writing bad ASL, and make sure that they have the right stuff in their hands as well.
Okay. All right, we'll definitely think of a solution to be transparent about our communication. Thank you.
All right, any other questions? We do have I know everyone's eager to get back to testing, but we got about 10 minutes left. I'm sure many of us have questions on ACPI that can only be answered probably at the evening reception with beverages. Because coming to one of the actually I believe, and Felix, you remind me, the first ACPI Plug Fest I remember is in this hotel, I think 20 years ago. I'm not kidding. Like I worked on ACPI 0.7 and 0.9, and knowing that there's a free drinks reception every night here from like 5 to 7 does explain some of the aspects of the early specification. But I'm glad that we've actually have enough time invested to continue to improve it. I think we're at the end of the cool questions. Remember, 3 o'clock in this room, come back. We'll have a nice break from testing and a chance to talk to the speakers in a little bit more detail, and we'll do this all again tomorrow afternoon. Thanks, everybody.